Welcome back. This is lesson number 6. In the previous lesson, we had an activity which was activity 5. And then this was the question. Here is the answer. X equals to -2 or x equals to 1 or x equals to 3. The chapter is still differential calculus. And today's topic, graphing a cubic function, meaning that we are going to sketch a cubic function. A cubic function is a graph of the form f of x equals to ax cubed plus bx squared plus cx plus d, where a, b, c, and d are real numbers and a is not equals to 0. It takes the shape of this form. For a greater than 0, for a positive. If a is positive, it means our function it will start by increasing, decreasing, then increasing. Or it takes this form. For a less than 0, meaning that if a is negative, our function it will start by decreasing, increasing, and decreasing. Okay, how do we sketch a cubic function? Step number 1, we determine the y-intercept, which is always the point 0 and d. Step number 2, we determine the x-intercept by letting y equals to 0 and solve for x. Stationary points, which is step number 3, we determine the stationary points. These are the points where the derivative is equal to 0. So it means here you differentiate and then you let f prime of x equals to 0 and you solve for x. Substitute the x value or the x values into f of x to get the y value or the y value. Okay, here comes an example. Sketch the graph of f of x equals to x cubed minus 3x squared plus 4. Solution. The y-intercept is the point 0 and 4. Now we determine the x-intercept by letting y equals to 0. So we have x cubed minus 3x squared plus 4 equals to 0. And then f of -1 equals to into -1 cubed minus 3 into -1 squared plus 4. And this gives us the answer of 0. Now what is the meaning of this? It means x plus 1 is a factor. So we factorize this expression using the factor x plus 1. So we're going to factorize it like this. Okay, I can see somebody is asking himself or herself, why or how did we factorize this? Okay, let me remind you. So we have our factor of which is x plus 1. Therefore we say x plus 1 into x squared plus px plus 4. Then we remove the brackets. Removing the brackets, we're going to have x cubed plus px squared plus 4x plus x squared plus px plus 4. Therefore we have px squared plus x squared equals to -3x squared. And then we take out the common factor, which is x squared. Therefore we have p plus 1 equals to -3. And then finally our p equals to -4. Okay, then we factorize this expression. Therefore we have x equals to -1 or x equals to 2. Then we have 2 points, which are -1 and 0 and 2 and 0. Now we determine the stationary points. And then how do we determine the stationary points? I said you differentiate the function and then you let it to be equal to 0. Therefore we have f prime of x equals to 3x squared minus 6x. And then we let this to be equal to 0 and we solve for x. So solving for x, we have x equals to 0 or x equals to 2. If x equals to 0, we substitute 0 into the original equation in order to determine the y value. Therefore, we have y equals to f of 0 equals to 0 cubed minus 3 into 0 squared plus 4 equals to 4. Therefore, stationary point 1 is the point 0 and 4. If x equals to 2, we do the same in order to determine the y value. Then y equals to f of 2 equals to 2 cubed minus 3 into 2 squared plus 4, and this gives us the answer of 0. Therefore, stationary point 2 is the point 2 and 0. Now listen to me attentively. Can you see this picture here? There is 0 and 2. Where am I getting this 0 and 2? These are the x-intercepts of the stationary point altogether. Okay, and then we have obtained these two values 0 and 2 when the gradient is equals to 0. So from the knowledge of analytical geometry, we know that a line which has a gradient of 0 is parallel to the x-axis. So as you can see, this part I've drawn it parallel to the x-axis, and again this part parallel to the x-axis. It means here when x is equals to 0, the gradient is equals to 0, it's parallel to the x-axis, and when x equals to 2, the gradient is equals to 0, it's parallel to the one, to the x-axis. And then I have written positive, negative, positive. So let me tell you about this positive. If we take any value which is less than 0, for example, we can take negative 1 and substitute it into this equation, we are going to get the answer which is positive. Therefore, it means our graph is increasing altogether. Okay, and then here at 0, the gradient is 0, so it means the line is parallel to the x-axis. And here between 0 and 2, if we take 1 and substitute it into this function, we are going to get the answer of a negative number. So it means our function is decreasing. And here at this point, it's parallel to the x-axis because at 2, the gradient is 0. And then if we take 3 and substitute it into this equation, we are going to get a positive answer. So it means our function is now increasing. So what is the meaning of this? It means the graph that we are going to draw, it will start by increasing, decreasing, and increasing. Okay, we have 3 points. The point 0 and 4, negative 1 and 0, and 2 and 0. Now let's have a look at our graph. As you can see, it started by increasing, decreasing, increasing. Activity 6. And then this is yours. Make sure you write this activity, and then I will provide you with the answers in the next lesson. And please make sure you don't miss lesson 7. And please don't forget to subscribe.